Hello and welcome to OWASP TimeGap theory training. Today we will learn how to find and exploit TOCTOU issues in web applications with OWASP TimeGap theory. My name is Abhi and Balakrishnan. I work as a security consultant in Security Compass. I'm from Thrissur. I'm living in Silicon Valley. I'm creator of all these projects listed over here. If you have heard of them before, great. If not, please Google this. I'm sure you will find at least some of them interesting. Little bit of disclaimer before going ahead. This is a personal project. It is not connected to my employer. Opinion, codes, and ideas are my own. This is our plan today. I'll give you the story behind OWASP TimeGap theory. I'll introduce the project to you. I'll walk through all the challenges and I'll give, in that process, you will learn some of the tools and techniques. You'll also learn some of the tips and tricks you can use while finding and exploiting TOCTOU issues. I'll also share some interesting stories and links so that you can go back home and check them out later on when you are trying this out in your home lab. Throughout this training, I may use these terms interchangeably, but I'm essentially referring to TOCTOU issues which are caused by race conditions. So I may say race conditions, time of check to time of use, TOCTOU, or concurrency issues, but generally I'm referring to TOCTOU issues. By the end of the session, you will be a TOCTOU champion. This I can promise. Now the story behind OWASP TimeGap theory. My day-to-day job involves sitting in threat modeling sessions and telling people what to do. I may look at the designs and say, hey, this particular software design looks good, but these are the issues that can arise. So I basically forecast the issues that can happen. Then I also suggest controls which can help us mitigate those issues or remediate those issues. Once I was in such a threat modeling session, I was looking at a piece of software design and I said, this can introduce TOCTOU issue in the application. Not surprisingly, most people sitting in that room did not know what TOCTOU issue was. So I had to explain. For example, imagine that you are going for a movie. It's a latest released movie. You want your favorite seat when you're going in. So if you walk into the theater and try to book a ticket from there, there is a high chance that you may not get the favorite seat you want. The obvious solution here is to book the seat online. You have decided to book the seat online. You are going to the corresponding website, checking if your favorite seat is available or not for a particular show that you are interested in. To your luck, your favorite seat is available. You are happy. Now you want to book the ticket. For that, you have to enter your credit card and contact information. You are entering all this information and clicking on the final Book Now button. Now there can be a spinning action that the application is processing or doing some communications in the background. You are expecting that you will get a message saying that your seat is booked, but you get an error message instead. It says the seat is gone. This can happen in multiple situations, not just while booking seats for a movie. It can happen, say, when you are trying to book a seat in train, in aeroplanes, trying to purchase something online, say for example, buying a particular stuff which is in very high demand during a holiday season. then if you try to purchase them from, say, like Target, Best Buy, or Amazon, you may see the same thing. What happened here? There was a time gap between the availability check, the time when you actually checked if the seat was available or not, and the actual booking, which means when you actually click the final book now button. So within that time, someone else claimed that ticket before you. Now the question is, what if both of you click on the book now button together at the same time? There are multiple things can happen, and practically the internet connections can be, one person's internet connection can be slower than the other. There can be distance factors, there can be latency factors, those type of things. But think of a scenario where all of them are same, or say, for example, there are compensating factors in place to compensate for this delay and distance, and both the requests are reaching the application at the same time. What will happen when that happens? Is the application going to prioritize one request over the other? Is that going to say, hey, I will give this seat or ticket to person A and will deny the request coming from person B? Or is that going to say, hey, I want give seats to both of them? But that is like that is not a good scenario, because the business is losing business just because of that. Usually when you design applications, even though the applications are multi-threaded, you code the application or you design the application thinking of a single thread, even though they are capable of running multiple threads. Now, what if both of you get the same ticket for the same show? What if the application honors both the requests? Then in real life, if both of them get the same ticket for the same show, you and the other person may walk into the theater and try to sit on the same seat. It can cause issues. Authorities may get involved, and they may say, hey, at least one of them, we will give you refunds, or we will give some other gifts or something to make you happy. Or you may file a police complaint, something like that, and they may blame technical error for this issue. So these type of issues can happen. When I said that, back to my story, when I said that most people sitting in that room did not believe me. They said, it is a corner case. What are the likelihood of this happening? Even if it is not happening organically, attackers can try to simulate that scenario, but even then it is very hard to exploit. It may require sophisticated tools to do that. Then there was another argument saying modern databases will take care of these type of issues automatically. Then few of the people believe that TOCTOU issues affects only money transfer kind of scenarios. If you Google race conditions TOCTOU, time of check to time of use, etc. on Google, you'll find hundreds of articles, blog posts, sample applications, videos, and all of them discuss about money transfer kind of scenarios. So there is a misconception in the industry that TOCTOU issues affects only that type of scenarios, and that is wrong. Over the next few months, I came across multiple such occasions. I wanted to shout out to the world that TOCTOU issues are real. But how? I asked myself. That's why I built OWASP TimeGap theory. OWASP TimeGap theory is a free and open source CTF-style vulnerable app. You can run it on Heroku or Docker. That means you can run it on your system or a system that is controlled by you. If you want to run traffic-heavy tools on them, or you can just spin a Heroku instance and do whatever light testing you want just to understand what TOCTOU issue is. It has bullet time feature. That is one of the main attraction point. What is bullet time feature? I will explain in a moment. It also supports dark mode and snow mode. Now, this is how home page of OWASP TimeGap theory looks like. Pay attention to the three buttons on top right hand corner. Score, settings, and web app. We'll be discussing about them now. The score page is where you can see all the challenges. You can see there are 7 challenges right now in OWASP TimeGap theory. And you can see respective points and also the status, whether you have completed the challenges or not. There is also a clear button on the bottom left hand side. If you click on that, all your progresses will be cleared. That means you have to start all over again. The web app directory is where all the TOCTOU challenges are. So you want to limit or focus all your testing efforts there. Settings page is where there are few settings. Main wait and Mars wait are the bullet time feature, which means the application will wait. Say for example, if I'm setting 3 seconds as the main wait period, application will wait 3 seconds before making any write operations to the database. Read operations will go through without any delays, but write operations will get delayed. If it is 0, there won't be any delay. Maximum logins is for brute force protection. We'll be using that as well in coming challenges. So we will discuss about them later on. Let's start with our first challenge, which is the sign up page. Usually in sign up pages, you will see name, password, and email fields. In some cases, just email and password. In OWASP TimeGap theory, you also get 4 buttons on top. These buttons are for filling the forms automatically. So if you click on Tom, it will fill the form with name as TOM, all small case, lowercase. The password would be again Tom, lowercase. Email would be tom@timegaptheory.com. Same goes for Jerry, Spike, and Tyke. If you are using Docker on your local machine, the URL for signup page would be localhost/timegaptheory/webapp/signup.php. If you are using Heroku version or a remote instance of Docker, this local host part may change. Now, look at the high-level flow of a sign-up page. First, the user will enter their email address and password. It can be email address or a unique username. Second, the app checks the database to see if the user's email address or username already exists on the system or not. Then, third and fourth steps are actually based on the decision on step 2. If application finds out user's email address or username already on the database, it will error out saying there is already an account registered with this email address. If a match is not found, that means it's a fresh email address or username. The app will create a new account and it will write that to the database. Let's look at the same stuff on this step diagram. You can see that the user is supplying email address and password on step number 1. The second step is our PHP application checking whether the email exists on the database or not. It is checking the database. Then based on this outcome, it will create an account or won't create an account. We are looking at the same thing again in a different manner. Sequence. Now it is a sequence diagram. Why are we doing this? It is to understand the situation at hand closely, and representing that in different diagrams will help us understand the flow closely, and it will help us understand issues that can occur. Now, there are three parties: user, our application, and the database, and there is a communication that's happening. Now this would be a happy path. User is supplying email and password. It asks, application checks the database if email exists or not, gets a response that no, saying no, this username or email address does not exist on the database. Then application will create an account by writing that particular email address and password onto the database. It will add a new entry. Now, what if the user is an attacker? They may submit the form using a script or from two different browsers or systems together at the same time. Then there will be two requests with the email and password. Both of them will go to the application. Application will process both of them. Since almost all the applications are application supports multi-threading, that's how they are able to cater to multiple users at the same time. Now the application will check the database. There will be two threads, and on both the threads, a database will say, hey, no, I don't see this particular email address or username on the system. Just one thing to remember, the supplied email is same for on both the requests. Now the application will ask the database to create the account twice. That means there will be two user accounts with the same email address on the system. That, at least that's a theory. Let's see it in action. We have the admin page. We are going to the admin page and resetting the application so that everything will be new. It is recommended to do that from time to time. That will help us. Say, for example, if residual data exists or as a particular data does not exist in the application, our attacks may not get successful. So in this case, it is recommended after solving each challenge to reset the database by going to admin. I just did that. Then I'm going to the sign up page, clicking on Tom, and it will pre-fill the form with the details of Tom. Done. I'm submitting the form. That means first user account is created with email tom@timegaptheory.com. Now we are submitting the form again, and we are getting an error message saying that account email address exists already. The first request went through because there was no duplicate, but now the second one is not going through since there is an application logic that is preventing us from creating a second account with the same email address. Looks good. Now we have two user accounts with the same. We have only one user account, tom@timegaptheory.com on the system. Now go to the settings and add a delay in main wait. So we are adding 5 seconds delay. I'm clicking on the update page, then going to the sign up page again. This time I'm filling the form with Cherry, and I'm opening two browsers and doing the same thing. I'm on both of them. I have user details of Cherry, and I will click on the submit button on the first browser, and immediately I will go to the second browser and will submit the submit button. And it needs to be done within the 5 seconds because our main wait delay is 5 seconds now. I've done that. I'm waiting for both the browser to load the pages. It will take some time because we have 5-second delay. Okay, now the pages are loaded. If you go to the manage users, admin manage users, you can see that there are two user accounts with the same email address, jerry@timegaptheory.com. If you go to the score page, you can see that you have scored points for completing the first challenge. Now, what would be the impact of such an attack? An attacker may be... Now, what would be the impact of such an attack? An attacker may be able to create multiple accounts with the same email address, and depending on the application design, it can have different implications. Say, for example, I am an attacker and I have a particular user I am targeting, and that user haven't signed up for an account in the application yet, what I will do is that I will create multiple requests for registering an account on the application with the user's email address, our victim's email address. Application will create them. Application may send a verification email to the original to the victim's email address, and victim will receive multiple emails, and victim will click on one of them and will complete the account creation process, or they may not. So if they do, they will own one account, but for all the other accounts, I have the credentials available. So whatever they do on their account, I'll be able to, as an attacker, I'll be able to go back to the application, log in with a different set of credentials, and may access money or some other data from the original victim's account. Now we know how to solve sign-up challenge using the bullet time feature. Now, bullet time feature is good. It is available in OWASP TimeGap theory, but in real life, there is nobody to give you that type of feature. So what will you do in real world? How can you exploit? How can you find TOCTOU issues in real world? Let's see how we can solve this particular challenge using Devtools. I'm going to the admin page, clicking on reset database so that we can start fresh. This core page is cleared as well. Now I'm going to the sign up page and I'm filling user details for Tom, then clicking on the submit button. If I do that again, the application won't let me because it will detect a duplicate email address entry. I'm going to the inspect element, then going to the network tab, submitting the form again, and now I have a sample sign up request. I'll right click on that particular request and copy it as fetch. Go to the console tab, paste it, and this time the request will be having details of Tom, and we need that to be changed because Tom account already exists. I'm changing that to Devtools so that we can see if it is successful or not. That is just one request. We need multiple requests. I'm copy pasting that particular request again and again so that it will there will be multiple requests. I'm just copying pasting it twice. Now I've submitted that. If I go to the managers, you can see that there are 2 user accounts with the same email address and name. That is how you can solve or you can find or exploit TOCTOU issues using browser Devtools. Now let's learn alternative method to solve. Now there's a third technique to find and exploit TOCTOU issues. It is by using curl. We will see how. I'm going to admin, resetting the database, go to the sign up page, then I'm clicking on inspect element, filling in the user details for Tom, and going to the network tab. So up until now, all the steps are similar to how we solved the challenge, this particular challenge using Devtools. I'm right clicking on the request again. Now, instead of copying it as fetch, I'm going to copy it as curl. I have copied the request as curl and pasting it on a notepad. I don't want these many data parameters, so I'm removing all those unnecessary headers and keeping only what is absolutely required for this request to be successful. How did I find that out? It was purely trial and error. I tried removing each headers and see if it is getting successful or not, the request, and if it is, then that means I can remove that particular header. All right, then I'm putting a space, then ampersand symbol, space again, then I will copy paste the request again, because if I send only one curl request, that means just I'll be sending only one request to the application, but I want multiple requests. So I'll club all of them by separating them with an ampersand symbol. Awesome. So we have two requests now separated by ampersand symbol. I'm copying that. I'm going to command line, and I'm pasting that. Okay, requests are successful. Let's go back and see. See, now you can see that there are two user accounts with tom@timegaptheory.com. One thing to notice here is that when we solve the challenge using bullet time, we added a delay in the application. When we solve the challenge using Devtools and curl, we did not use that feature. So in real life, you can use Devtools and curl to find and exploit TOCTOU issues. Now we will look at a fourth method. It is by using a tool called Raise the Web. Raise the Web is a tool developed by Aaron Native, who's a former colleague of mine. It's an open source tool. It is written in Go. One thing I love about this tool is specifically designed for exploiting TOCTOU issues. Plus, it is CI/CD friendly, which means a lot to me because you can use this in your organization easily. Now let's see how we can solve this particular challenge, sign up challenge, using Raise the Web. I'm clearing my score. I'm resetting the database. I'm going to manage users. And this is a TOML file. A TOML file with the request details needs to be supplied to Raise the Web tool so it can work. And it is fairly easy to create a TOML file. It just needs to, the extension is .toml, and then you can see that there is a count on the line number 3. There is a count, and the count is 10. That means the Raise the Web tool is going to send 10 requests. I'm turning the verbosity level to false. That means there won't be much details, request and response details on the screen. Then whatever request you want to send, you need to specify them under double these square brackets, the double square brackets. You have to say request and then the request details. You can see the method is post. URL is whatever URL you want the data to be sent to, and the body of the request. Now that I have created the TOML file, I will supply the TOML file to Raise the Web tool. All right, we have executed Raise the Web. Let's refresh the page, and you can see that at least 3 of them were successful, and there are 3 user accounts on TimeGap Theory system with the same email address and first name. Let us look into the second challenge, which is a login page. In login page, you will usually have username and password or email address and password. In our case, it is the same. The screenshot you are seeing is is of sign up page, but in login page it will be just username and password. Similar to the sign up page, you will be having 4 buttons over there, and you can click on them and it will fill the form automatically with the user details for that particular user. The login page URL is localhost/timegaptheory/webapp/login.php. Now look at this diagram. It is about how a login page works in a very high level. On the very first step, the user enters the username and password. The application, in our case, it is a PHP code. It will check that username, password, and password on the database. But in our case, there is login count as well. Why is that there? It is to prevent brute force attacks. So say, for example, an attacker is trying to guess the password of a particular user. They may try 1 2 3 4 5 6 first, then 1 2 3 4 5 7, 1 2 3 4 5 8, and they will try all these various passwords, and we want to prevent that. In our settings, there is a field in which we can specify how many times the attacker can try before their account gets logged out. So if it is 3, it means the attacker can supply the correct username but wrong password 3 times, and then the account will get logged out. Once the account is logged out, even if you supply the correct username and password, the application won't let you log in. So in the first step, the user is entering username and password. The app, on the second step, the app checks the username, password, and login count on database. Now, based on the outcome of this particular check, there is a third step. If a username password match is found and the login count, incorrect login count is less than 3, which means a brute force attack is not detected, then the app will create a user session, which is the happy path. There is another scenario wherein which an email match is found, but the password is not matching. That means an attacker is trying to, the application assumes that it is an attacker trying to brute force the account. Then the app will find that particular database entry for that particular user or email address. Then it will increase the login count. So if it is 0, then it will get increased to 1 on the. If the user supplies a wrong password again, the incorrect login count will increase to 2, and it will keep on doing that. There is a fifth step. If an email is not found on the system, obviously the application will throw an error. Now look at the happy path. Let's look at in a very detailed manner. So there is the attacker trying to brute force the account, and obviously the attacker, instead of attacker trying it one by one, attacker is sending parallel requests, and all these requests will go to the PHP application. The application will check the database. It will check if it can find a username and password match. It will also check the login count. And if a username password is found, the application will create a user session. Now, only if the login count is less than 3. Now, how we can exploit this type of flaws? First, we will exploit this with the help of bullet time feature. I'm going to web app, creating default users. When you click create default users, it will create 4 user accounts with Tom, Jerry, Spike, and Tyke. That way you don't have to go through sign up process again. All right, now I'm going to web app, clicking on admin and creating default users. When you do that, the application will clear the database and create 4 users, Tom, Jerry, Spike, and Tyke. Now that is done, let's log in with Tom. Yes, login is successful. Let me log out. This time I'm submitting the form with an incorrect password. Let's do that a couple of times to see if our brute force prevention mechanism is working out or not. So first it is saying login is failed, but it's saying email access on the system. That means the user account is on the database. Now, after a few tries, it says the account is logged out. So Tom's account has logged out. I have changed the maximum login attempts to 1. That means if the user enters wrong password even once, the account will get logged out. Now I'm going to manage users. You can see that Tom's login count is 1, incorrect login attempt is 1. That's why their account is logged out. I'm going to settings page and adding 9 seconds as the main wait delay. Looks good. I'm saving the form. Going to login page again. Since user account of Tom is logged out, we will use Jerry's account this time. And I'm filling the form with Jerry, and I'm typing an incorrect password. I'm opening an incognito window or private window of the browser and navigating the login page. Again, clicking on the Jerry button and typing in a wrong password. And I have opened another browser, did the same thing, and I'm opening private window of that second browser, and I will do the same. This time I'm supplying the correct password. Now I need to click on the submit button on all the browsers as fast as I can within the 9 seconds window. We will wait for the pages to load. The page loading time will be slightly longer than usual because of our 9 seconds delay. You can see that at least in one of the browser, the login attempts was successful. If you look at Jerry's incorrect login attempt count, you can see that it is 3. There is no way that could have happened if we sent one request after the other. However, we sent multiple parallel requests, and that is why even though login attempts count went beyond 3, we were able to get one successful session in one of the browser. If you go to the score page, you will see that you have gained points for solving the second challenge. Now, let's see how we can solve the same challenge using browser Devtools. I'm clicking on user Tom. Let's see how we can solve the same challenge using browser Devtools. I'm creating default users on the system, clicking on the login button, and I'm logging in as Tom. Login is successful. Now I'm submitting the form again with wrong password. First attempt is failed. Second attempt is failed. Third attempt is failed, and your account is locked out. So we know what is the account lockout threshold. We will right click on the page and click on inspect to open browser Devtools. Then we will navigate to the network tab of the browser. We will supply the Tom's user accounts again so that we can get a valid request. Right click on the login.php page, copy it as fetch. Go to the console tab of the browser Devtools and paste this particular request. Then the body will be having request parameter details of user Tom. We need to change. We have to change that to Jerry. Looks good. We are changing the password to an incorrect one. Then we will copy paste this particular request a couple of times, and in one of them we will provide the correct password. In all of the others we will be giving wrong passwords. So in real life scenario, these incorrect passwords won't be the same. We will be trying potential passwords. Say for example, it can be something that is derived from a dictionary, or if it is brute forcing, we will be using a particular pattern, a set of character sets. Now, once that is done, we will be having a set of requests with only one correct password, and all of them others would be wrong passwords. And when we click on the submit button, all of these will go in parallel threads. Now we are submitting the request. If you go to the network tab, you can see that there are multiple requests that is going to login.php page. And if you look at the response status, you can see that only one of them got 302 response, and 302 indicates a successful login. It is redirecting to a user page, which means that request will be having the correct password. If you right click on that, if you click on that, you can see Jerry is the correct password, and click on the subsequent request and open it in a new tab to get an established user session. If you go to the scores page, you will see that you have solved the second challenge using browser Devtools. If you look at the manage users, you can see that the login attempts count for user account Jerry is now 4. We will start with the third challenge now, which is the transfer page. This is the typical scenario of race condition you see regularly on the internet. In this scenario, there will be a from field, a to field, and an amount which you need to transfer. This is how a user money transfer, rewards transfer page will work like. First, the user will initiate a transfer. The app will check the user balance on database. If sufficient balance is available on the user's account, the application will add corresponding points, money, or rewards to the destination, and will make that changes in the database. Then the app will reduce the same amount of money, rewards, or points in the user's account and will make the corresponding changes in the database. Then, say for example, if a sufficient balance is not available, app will error out. We are looking at the scenario again. We have the user initiating the transfer. The PHP application is checking the database to see if the user has sufficient balance or not. If sufficient balance is found, the third step, which is the happy path, the user's whatever the value is will get added to the destination. First step, whatever that amount will get reduced from the source, and the transaction completes. The non-happy path, the app will error out on fifth step if the application finds out that there is now sufficient balance in the user's account. Now we are looking at only at the happy path. The user has initiated the transfer, and we are looking at the happy path with 2 threads. So the user initiates transfers within the limit. There are 2 threads. Application checks the balance on the user database. Since both of the requests are within the limit, it will check the database and both of them will get a message saying that the user has sufficient balance. Both threads will get executed by the application on third step, and the corresponding changes will be made in the database. Let's see how to exploit these type of scenarios in using bullet time feature in OWASP TimeGap theory. I'm going to the score page to make sure that this challenge is not scored. We have delay set to 0. I'm going to admin page and creating default users. I'm logging in as Tom. You can see that I have 100 reward points on my account. So whatever amount I'm transferring should be lesser than the 100 points or equal to. I'm transferring, so if you can, there are 2 buttons on this UI. You can click on them to fill the form and add some values there. If you don't want to manually type them, you can manually do that as well. So now I clicked the second button, so it will transfer $90 from Tom to Jerry. $90 is within my $100 limit, so it will go ahead, $100 or 100 points. So this transaction will go through. It happened, and I'm trying that again, and when I did that twice, the transaction did not go through. It's saying I don't have enough rewards, which is expected. I'm going to admin and creating the default users again, logging in as Tom again. Now I'm going to settings and adding some delay for bullet time feature to work. Then logging in as Tom again. It is taking slightly longer time because of the bullet time feature we have enabled. I am opening a private window of the browser and navigating to the same page. We'll go to the login page, we'll log in as Tom, and then I'll go to the transfer rewards page. Alright, I'm going to manage users and making sure what is the rewards points. So you can see that Tom has 100 reward points, Jerry has 900 reward points. And those are the two accounts we are looking at for now. So on both of them, I am putting $90 on both the browsers. Now I need to click on the transfer button on both the browsers as fast as I can. We will wait for both the requests to finish. Alright, the pages have completed loading. If you refresh this page, you can see that Tom had only 100 reward points. So if that gets completely transferred to Jerry's account, Jerry earlier had 900, and the 900 plus 1, the balance would be 1000. But Jerry has got 1080, 80 points extra. If you look at Tom's account, you can see that 80 points, where it is coming from. It is showing up as a negative balance. If you go to the score page, you will see that you have earned points for completing the third challenge. This is how you solve third challenge using bullet time feature. Of course, you can do that in real life. You need some other solutions, and we will use browser Devtools to do that. Alright, I'm going to admin, creating default users. I'm logging in as Tom. I'm going to transfer rewards page. This time I'm putting $10 to be transferred from Tom's account to Jerry's account. I'm right-clicking on the page and clicking on Inspect to open browser Devtools. I'm going to the Network tab of browser Devtools. I'm clicking on the transfer button. If you scroll up, you will see a successful request that is going to transfer rewards.php page. Copy it as fetch. Go to the console tab of the browser Devtools. You can see that since 10 points has been transferred already, Tom only have 90 points in their account now. I'm pasting that particular request, and the request has 10 points as the amount. I can remove all the unnecessary headers from the request to make it look easy on the eyes. Alright, I'm changing the value to 90, which is our maximum limit. Then I'm changing the final semicolon to a comma. Then I will copy this particular request and will paste it few times. All of them has 90 as the amount of rewards to be transferred. I'm finishing it with a semicolon, clicking enter. Now if you refresh the page, you will see that I have minus 180 reward points. It's a negative balance for sure. If you go to the score page, you will see that you have completed the challenge successfully using browser Devtools. Now let's see how we can solve this same challenge using curl. I'm going to admin, I'm resetting the database and creating default users. I'm going to login page and logging in as Tom. I'm navigating to transfer rewards page, clicking on $10 from Tom to Jerry button, clicking on inspect element to open up browser Devtools. I'm clicking on the transfer button and going to the network tab of the browser Devtools to see the request that is going from the browser to the web application. I'm right clicking on the first request and copying it as curl this time, not as fetch. I'm pasting it on Notepad. Now I can remove all the unnecessary headers. That will make things easy on our eyes. We can change the amount to 90. That is our upper limit, because since we have only 90 reward points in our account. I'm putting a space and then ampersand sign, a space again, and then pasting the request. Now we have 2 requests. We will add few more. This way we'll have multiple threads going from our command line to the application. Alright, we have 3 parallel requests that will be going. Let's see how many reward points Tom has. Now Tom has 90 reward points before executing our curl command. Let's execute the curl command and see what will happen. Okay, it is successful, and yes, we have minus 190 reward points. Now that we have solved this particular challenge using Devtools and curl, let's see how we can solve the same challenge using Raise the Web tool. For Raise the Web tool, we need to supply a TOML file. We will look at that TOML file in a second. This is the TOML file. I'm putting count as 3 and it has the request details. Let's change that count a little. Alright, now we will launch the Raise the Web tool. And if we refresh the page, hey, now we have minus 200 reward points, which means our attack was successful. We will look at the 4th challenge now, which is called Mars. Ticket to Mars is not a feature that you will normally see in web applications, but we will look at the scenario just for an informational purpose. So in Ticket to Mars program, what is happening is that it is going to be an admin page. When admin clicks on this page, or it can be scheduled to run at a particular time. So once it's executed, it will go through all the user accounts and we'll see which user account has at least 200 reward points. If a user has 200 reward points, they will get the idea is that they will get an email and they will get a ticket to Mars. That's the idea, but our application is not sending any emails. It is just a theoretical idea. So this is how it will be in a real life if it were to happen. An admin will be kickstarting this operation, or a cron job will be kickstarting the operation. The app will check each user's balance one by one on database. App will check if the user's balance is greater than the particular amount, which is 1,000 or 2,000, whatever, however it can be. it is up to the business owner's discussion to determine that amount. If the balance is greater than that particular threshold, the app will send a ticket or add points, then it will move on to the next user. Alright, so we are looking at the same thing, using a separate diagram. Now, what if a user transfers some reward points between accounts once the script has triggered? What will happen then? That is our question, and we will see it in action. So we will see it with the bullet time. So if I go to admin, create default users, it will create all the user accounts and some balances on them. And if I click on Ticket to Mars, you can see that it says the first 3 accounts are not eligible since they don't have enough balance. Last account is the only account that is eligible. If you go to administration panel and manage users, you can see that Tyke is, or the last user, is the only user who meets the criteria, who meets the threshold of 2000 reward points. Now, I'll go to the login page, login as Tyke, and I'm transferring my rewards to Tom's account. I'm trying to transfer the whole amount. Alright, I have transferred the whole amount from my account. So if you go to manage users, you can see that Tom has 2100 reward points now, and Tyke has 0 reward points. Now, I'm opening a private window. I'm going to login page, logging in as Tom. I'm clicking on transfer rewards. And I'm transferring money from Tom to Tyke, and I'm transferring 2000 reward points. I haven't clicked the submit button yet. I'm adding a delay. I'm enabling bullet feature time only on the Mars program by adding a delay point in Mars wait field. Alright, I'm submitting that form. Now I'm clicking on the ticket to Mars, and it will trigger that script, and the application will start going through each users now, and the application would have started with the first account. So Tom, immediately after clicking this button, Tom would have received ticket to Mars, since the application would have checked their account first. We need to transfer reward points from Tom's account to Jerry before the application reaches to Jerry's account. So click on the transfer button as soon as you can. Now wait for the ticket to Mars script to finish. Now you can see that both Tom and Tyke received the ticket to Mars. If you go to manage users, you can see that Tom only has 100 reward points now. If you go to the score page, you can see that you have earned points for completing the 4th challenge. We will look into the 5th challenge now, which is named tickets. In this challenge, there is only one ticket available for all the users, and whoever clicks on the buy one ticket first will get the ticket. Now, this is how a higher level flow would be. User will be trying to buy a ticket. The application will check the DP to see if someone else has booked the ticket or not. If the booking is not done yet, the application will create a new entry. It will create a new ticket, and it will assign to that user. Will make corresponding change into the database. If a booking is already found, the app will error out. Now, what if 2 users or more than 2 users try to buy the same ticket at the same time? app will check the number of current bookings on DB, and it will not find any tickets there since none of the users has purchased the ticket so far. And the app will get that message. The app will create 2 tickets since there are 2 threads. If there are 2 more users, all of them will get no bookings found message, and all the threads will create new tickets. Let's see if we can do that using bullet time feature. I'm going to web app, going to admin and creating default users on the system. Now I'll go to the score page and clear everything so that if everything will be clear. I'll go to the score page and will clear everything. Then I'll go to the login page of the application, will log in as Tom, and will try to purchase a ticket. Alright, I am able to buy 1 ticket, but if I try to click the buy 1 ticket again, it is not getting on it. I'm logging in as Jerry and clicking on the buy 1 ticket button, but I'm not able to since the first user already purchased the ticket. I'm clearing the database, creating default users. I'm going to the settings page of the application, adding some delay to enable bullet time feature. Once that is done, I will go to the login page again and will log in as Tom. Now we need multiple threads. For that, we should use 2 different browsers or an incognito or private window of the same browser. I'm logging in as the same user there. Navigating to buy tickets page on both of them. Now we need to click on buy 1 ticket page button on both the browsers as fast as we can. We'll wait for the pages to finish loading, and once that is done, we will refresh the page, and you can see that I was able to purchase 2 tickets for the show. If I go to score page, I will see that I got points for completing the 5th challenge. This is how you export this issue using bullet time, but that is not possible in real life. So let's look at a real life scenario. We will solve this challenge using Raise the Web tool. I'm logging in as Tom, clicking on buy tickets button. I'm inspecting element to see the session ID. That is important since this page is authenticated. Earlier, the money transfer or reward points transfer page, even though it looked like authenticated, it was not authenticated. That's why we were able to solve those challenges using simple requests without supplying any cookies. But since this page is authenticated, you need to supply the PHP session ID as well. All right, we have 2 different PHP session IDs. We need to from 2 different browsers, and I'm executing that. Once that is done, we will see whether it was successful or not. If I go back and click on buy tickets page, I can see that I have 2 tickets. Let us look at challenge 6, which is coupon. In this challenge, user will enter a coupon code. If valid, app will check if it was used by the user before or not. If not used before, the app will aware that particular points and will make the corresponding changes to the DB, and it will also toggle the coupon usage status on DB. Otherwise, if the coupon code is not valid, or if the coupon was already used by the user, the app will error out. Now, what if user tries to use the same coupon multiple times in parallel threads, both of them will get the valid message from the database. It will all application will also get a message that the coupon was not used before, and the application will award the points 2 times to the user. Let's try to solve this challenge using bullet time feature first. I'm going to web app and resetting the database and creating default users. Now I'll go to score page and make sure that I'm not already scored for that particular challenge. I'm going to login page and logging in as Tom. Now I'll click on enter coupon page. Here there are 2 buttons on top, valid coupon and invalid coupon. If you click on valid coupon, it will fill the form automatically with the valid coupon. If you click on invalid coupon, it will fill the form with an invalid coupon. Now it says you have 100 reward points already. Let's see supplying a valid coupon. So if I supply valid coupon, I will get 500 reward points added to my account. If I try to do that again, I won't get reward points because since I have already used that coupon code. I'm logging out. I'm adding main wait delay to enable bullet time feature. I'm clicking on login and logging in as Jerry this time. Tom's account is already used. I'm doing the same thing on a private window, logging in as Jerry. And in both the browsers, I will navigate to the enter coupon page. I'll click on valid coupon on both the browsers. Then I will click on the submit button as fast as I can on both the browsers. We will wait for the pages to finish loading. Okay, see, I have got 100 and 900 points. That means I was able to use the coupon twice, and when you go to the score page, you can see that you have scored points for completing that particular challenge. Let's try solving the same thing using browser Devtools. I'm creating default users. I'm clicking on login. I'm logging in as Tom on this browser. I'm clicking on enter coupon. And I'm supplying invalid coupon this time just to get a request. I'm submitting the page. And when I go to network, I can see that particular request. I'm copying it as fetch. Now I'll paste it on a notepad and I'll collect the valid coupon and paste it on the notepad. Awesome, we have a valid request now. Now we need to remove all the unnecessary headers from the fetch request. Now I'm changing semicolon to comma and I'm pasting the request a couple of times to make parallel threads. I'm copying that. I'll go to the console tab of the browser Devtools, paste the collection of requests. You can see that it is just 100 reward points now. If I'm pasting it and I'm pressing enter. If I refresh the page, you can see that I have got only 600 reward points. That means only 500 reward points got added. What happened this time? The attack was not successful. The attack was not successful because there was PHP session involved. This page is a logged in page. So when PHP sessions are involved, browser Devtools cannot be used for exploiting TOCTOU vulnerabilities because application PHP will be able to track these sessions, and using them they will queue the request parallel threads that are coming from the browser and will execute it one by one, which means using Devtools on logged in pages are not going to work when exploiting race conditions. Let's see how we can solve the challenge using curl, whether we can solve the challenge using curl. I'm resetting the database, creating default users. logging in as Tom. I'm navigating to enter coupon page. I'm supplying invalid coupon this time, going to inspect element to open browser Devtools, submitting the page, and copying the request as curl this time, not fetch. I'll open Notepad and I will paste this particular request. We need to remove all the unnecessary headers from the request. Now we know the valid coupon is welcome 10. We need to update that in our request. Now this is just one request. We need multiple parallel requests. In curl, we need to do that with double ampersand symbol. So I'm just doing that. I'm opening a different browser window and logging in as Tom again and clicking collecting PHP session ID from there. Why we are doing this? It is done so that we will get two different sessions. If we have two different sessions, then PHP won't be able to queue the requests. That way, all the threads will get executed at the same time. That is why it is important to supply two different PHP session IDs or session IDs or cookie values. Now that we have two different session ID values, we will copy the set of curl requests we have. We will go to the terminal, paste this set of requests, and enter. Now we will solve the challenge using Raise the Web. I am resetting the database, creating default users, logging in as Tom. I'm copying the PHP session ID and supplying two different session IDs. We will need two unique PHP session IDs. That's why I am opening a new browser and navigating to the same page by logging into TimeGap theory. Then we will collect PHP session ID from there. We have only 100 reward points now. Let's execute the script. Awesome, we were able to solve this challenge using Raise the Web. We'll look at the next challenge, which is ratings. In ratings, what we do is, it is just like or 5-star system or love in social media networks. You can only like or rate a particular post or video or photo once. If you say, for example, if it is Facebook or Twitter, if you like it once, if you click on the button again, it will remove that like. Now, let's exploit race conditions or TOCTOU issues in those type of scenarios. First, we will see the issue through bullet time feature. I'm going to admin and clearing the database, adding default users. I'm making sure that in the score page I haven't scored for this challenge already. I'm logging in as Tom and going to rate the program page. So if I click, I'll show that again. If I click on the allow button, it will say you have 1 ratings, and if I click on it again, it will say you have no ratings. So it is being removed. I'm logging into the application from a different browser and logging in as Tom. Now I'm going to admin on the first page, then to the settings and adding main wait delay to enable bullet time feature. Now I'll click on the allow button on the first one and the second one, the browsers, as fast as I can. We will wait and see we have 2 ratings. We were able to like or love the same post twice from single account. Now we will see how we can solve the same challenge using Devtools. I'm resetting the database and creating default users, logging in as Tom on first account, first browser. Clicking on love and seeing if it works or not. I'm going to inspect element, going to network tab and click on love button to get a sample request. I'm copying it as a fetch, going to console. Now I'm taking notepad and pasting it, and so that we can clean this up, we can remove all the unnecessary headers. We just want bare minimum request for the request to be successful. I'm copy pasting that request multiple times, all separated by a comma, ending with a semicolon. I'm copying that, pasting it over a console tab of browser Devtools and pressing enter. Now if I refresh the page, it says only you have only 1 rating. So this is again the other issue we have seen before. The session cookie is actually affecting our ability to exploit the issue properly. Now let's see whether we can solve this using curl. For using curl, we will do the steps like we did before. We are logging in as Tom in one browser, navigating to rate the program page, and we will do the same thing on our second browser. We will go to the login page and log in as Tom. Now we need to go to rate the program on the browser, then inspect element, go to network tab, click the love button once. Now we have one request, copy it as curl, paste it in a notepad, then remove all the unnecessary headers. Note down the PHP session ID and CSRF prevention value. That is going to be different when you do this from the first browser. So we are doing the same thing on the first browser, copying it as curl, going back to the notepad, and we will, with two ampersand symbols or one, we will paste the second request. We will clean this up, but this time, if you look at the request carefully, the PHP session ID values are different. Plus the CSRF prevention token is different. We'll copy it and we'll go to command line, paste these two requests and press enter. Awesome, we successfully exploited this issue using curl. Now we will see how we can solve the same challenge using Raise the Web tool. I'm opening up two browsers, logging in as Tom on both the browsers. Now getting to write the program page. Now we want PHP session ID value and CSRF prevention token value from both the browsers. We can get PHP session ID value by going to application, storage, then cookies. So we have first PHP session ID. If you inspect the love button, inspect that form, you will get CSRF prevention token. We have the first set of requests ready. We need to do the same for the second request. First, we need to obtain the CSRF prevention token. Then we need the PHP session ID value, which can be obtained by going to application, storage, cookies. Perfect. Once the URL is corrected, we will run this. We will supply this toml file to raise the web tool. Let's see what will happen. If you go back to the page and refresh it, you'll see that you have 2 ratings. So we have successfully exploited this particular challenge, ratings challenge, using Raise the Web tool. A few trivial items. One thing, PHP is not immune to TOCTOU. That is one of the misconceptions we have amongst people, that since PHP is not capable of handling multiple threads, it is not vulnerable to TOCTOU attacks, or the platform it runs on, say like Apache, is capable of running multiple threads. Because of that, PHP inherits TOCTOU issues from the platform it is running on, whether it is Apache or Nginx. The transfer rewards challenge we have seen, Starbucks had similar issue back in 2015. Basically, you purchase a few gift cards, you keep transferring money between them, and if you are successful, you will make money out of thin air in a gift card. Then, since these are gift cards, these are not tied to any user account, so even if one card gets negative balance, you don't have to worry about it. You can just throw it away. There are lots of bug bounties being reported these days, which are TOCTOU and race condition. Majority of them are focusing on transfer money, transfer rewards kind of scenarios. Hopefully that will change in future. People will be able to find more issues with the help of projects like OWASP TimeGap theory and Raise the Web tool. TOCTOU was never in OWASP top 10 or SANS 25, but that doesn't mean it is any vulnerability that can be ignored. In most cases, attackers need just one open door to get into the system. As a defender, whoever is in the role of defending systems, they need to make sure that all the doors are closed, or whatever vulnerabilities they can mitigate or remediate, they should be trying to do that. So many people have the habit of just following OWASP top 10 or SANS top 25. In those cases, TOCTOU wouldn't be under their radar. In 1993, at least 3 patients died and several people injured due to a race condition issue in a radiotherapy system. The Northeast blackout of 2003 which was a widespread power outage here in the US and Canada, was also caused by a race recognition bug. We have also released a book on this subject called OWASP TimeGap Theory Handbook. You can get to know more about this book from timegaptheory.com/book.html. You can either purchase the hard copy or you can obtain the PDF soft copy version of it for free from our website. I have also written a TOCTOU poem. I'm not singing that now, but it's inspired by the Spanning Tree Protocol poem. So we have something similar for TOCTOU. These are the people who were involved in bringing this project to you. They contributed to the project, to the book. They tested the product. So I'm thankful to all of them for contributing their time to this project. You can help us grow. Please help us by spreading the word. Please help us by creating YouTube videos or posting somewhere about it. Or you can talk about this project in your close vicinity, in your organization, in your friend circle, or wherever you are, where you have some audience. If you want to contact us for any reason, we have a Reddit subreddit. So it is r/TimeGap Theory. You can contact us there. That would be all on behalf of OWASP TimeGap Theory. I thank all of you for attending this training session.